Hello everyone, welcome back to the channel. In our first video, we cover basic of coding Python, and in our second video, we cover data preparation. It's our third lecture in which we cover exploratory data analysis. So let's start our topic. So data analysis. It is a process of analyzing data sets to summarize their key characteristics using statistical and visual techniques. What is goal of EDA? So understand the data, uncover patterns, detect anomalies, test hypotheses, and set the stage for machine learning. Then this is the content which we cover under EDA. First is how to construct a bar graph with overlay using Python. Then how to construct consi- contingency table using Python, then how to construct histograms with overlay using Python, and last is how to perform binding based on predictive values using Python. So first is bar graph with overlay. A bar graph with overlay is a type of data visualization where a bar chart is combined with an additional layer of information to provide more insights. The overlay can be another set of bars, a line, or any other visualization element added on top of the bar chart. Types of bar charts with overlay. So first is stacked bar chart with overlay, in which two data sets are stacked on top of each other to show cumulative or comparative values. Second is grouped bar chart with overlay, bars for different data sets and placed side by side for comparison. Now guys, third is bar chart with line overlay, which is represent one data set and a line overlay shows trends or averages of another. Now, if we implement a stack bar chart, so let's see how we implement. First, we import matplotlib.pyplot as PLT library and import pandas as PD. Now, example of that is data category, which we have A, B, C, D with their respective values 10, 20, 15, and 25, and value 2 is 12, 18, 22, and 28. Now data frame is pd dot data frame data. Now we plot. So figure ax is plt dot subplots ax dot bar df category df value 1 label is assigned dataset 1 alpha 0.7. Now in second category df value second we assign dataset 2 alpha 0.7 bottom data frame value 1. Now set title, we bar graph with overlay and we show TLT. Then this is the output with which show a stack bar chart with overlay. As you can see here, we have all category, and in y-axis we have all values, and that is in the stack form, as you can see. Okay, so second is grouped bar chart, in which we have a category on x-axis and values on y-axis. Here we show the dataset 1 and dataset 2 in two different columns, as you can see it, but in last we show it is in stack form, right? Now third one is bar chart with overlay. So here we show the category on x-axis and values on y-axis as same as last grouped bar or stack bar chart, but here we show data set 1 with blue color columns, as you can see, and data set 2 we show with the help of red color line, right? So how to construct contingency tables? So for construct contingency table in Python, or we first import pandas as PD, then data we have feature 1 ABA CBA. Now feature 2 we have XYX XYY, and data frame is PD dot data frame data. Now contingency table, how we construct? So its syntax is contingency table is assigned PD cross tab data frame feature 1 and data frame feature 2. Now print contingency table. So we get contingency table like this. Here we have feature 2 is X and Y, and feature 1 is ABC, and A is 2, 2 count in X and 1 count in Y. And B is 0 count in X and 2 count in Y, as you can see. And C is 1 count in X and 0 count in Y. Now, after contingency table, we will discuss create a basic histogram in matplotlib, right? So import libraries, import matplotlib dot py pplot as plt, then import c1 as snc, and load the erase dataset, data snc, load dataset erase, then we print data head 5. So here we get our data set, right? Then we will plotting histogram. So how we plot? So first we plot histogram data, petal length, then label assign petal length, then histogram data sepal length, label assign sepal length, then plot legend, then upper right, then plot title, overlapping, then show. So we get overlapping like this, as you can see. Here sepal length is denoted by orange color and petal length is denoted by blue color, as you can see. Now how to perform binding based on predictive value using Python. So binding based on predictive values refers to dividing continuous data into discrete binds or categorized based on their relationships to a target variable, typically using a predictive model or some form of supervised learning. The goal is to create bins that maximize the predictive power of each bean with respect to the target variable. Got it? Now, binding, how we perform binding? So here we have code for that. First we import pandas as PD, then import numpy from sklearn model selection, import train test split, then from sklearn linear model import logistic regression, then from sklearn preprocessing import kb discretizer, then from sklearn metrics import accuracy score, right? Then sample data as a data assign feature np random rand 1000, then target random choice 0 to 1 size is 1000. Now data frame is assigned pd data frame data. Now we split the data into training and testing data. So how we xtrain, xtest, xtrain by test, right? So train test split is df feature 1, df target, test size 0.2, random state 42, right? So here we fit a predictive model. Model is assigned to logistic regression, model.fit xtrain, x by train. Now get predicted probabilities for the feature. How we so why probabilities model predict probab and extend is one use K-mean discretizer to bin the probabilities. So how K-means assign K-means discretizer and beans is 5. Encode is original strategy is uniform and you can experiment with uniform, quantile or k-means as well. Now explain xbean is assigned k-beans fit and transform by probes phase, right? And adding bind data to the original data frame. So df bind feature is assigned pd cut this, and as you can see, so we move to output. So here we get output accuracy of the bind model 0.545. Now explanation. In this case, the bind feature is constructed from predicted probabilities which are divided into 5 bins using k-bin discretizer. The accuracy printed is based on how well the logistic regression model performs when trained on the bind data instead of raw probabilities. That is all about exploratory data analysis. Thank you for watching this video, guys. Thank you.